Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an associate professor in the Department of Electrical and Electronic Engineering. In today's class, we are going to discuss about the two-port networks, and also in the two-port networks, we are having the various two-port parameters. The various two-port parameters also we will discuss in this today's class. So this two-port network and the graph theory, these are the two different topics. These are in the module 5, and we have already discussed about the graph theory. So now we are going to discuss about the two-port network parameters and what are the various two-port network parameters, and how we can convert the normal electrical circuit into two-port representation, and what is the relation between the two-port networks. I mean, of course, as I said, there are various two-port network parameters are there. So, what is the relation? And internal, what is that? The interrelation between these various two-port network parameters, that also we will discuss in this class. And then the two-port interconnections also, like if there are two different types of two-port networks, then how we can interconnect these two-port networks, that also we will discuss in this module. So, first let us start with what is meant by the two-port network. So, here, as you can see, especially when we are dealing with the complex circuits, okay, so are some kind of amplification circuits or the filters. So for the various circuits, if you want to develop, okay, or if you want to model that particular circuit, then we use the two-port network model to model that particular circuit. So usually the two-port network is represented by what is that, two ports, which is nothing but the input port and output port, and every port having the two terminals, right? So which means the input port two terminals having the two variables, and the output port having the two terminals, so the two variables. So which means the variables, we usually the four variables that we will be having. So the input variables we usually consider as a V1 and I1, and the output variables we usually consider as a V2 and I2. So actually there are various ways to relate these variables by using these two-port network parameters. So here, as you can see, so this two-port network is nothing but this is the old circuit, that electrical circuit that we are converted into the two-port network. And here usually this is the let us consider here this is port 1 and this is the port 2. So here the port 1 having the two terminals, namely 1 and 1 dash, and the port 2 also having consisting of the two terminals, namely 2 and 2 dash. So this kind of configuration is called the two-port network representation or two-port representation, right? So in other words, of course here the variables which we are considering for the input and output side. So usually, because this is an electrical circuit that we are converting into the two-port network, so the electrical parameters are voltage and current. So that's why here the input side, the current is, let us consider here it is I1, and the output side, I mean the input side voltage across these two terminals and the across the port 1 terminals is V1 of S. Then similarly here the current is I2 of S and the voltage is V2 of S. Then when coming to the two-port network, okay, so actually there are different parameters that we use to analyze this two-port network. Okay, so if the network is a linear, that is each variable can be expressed as a linear function R of some of the two other variables, then we have the following models, that the two-port network parameters. So the two-port network parameters, I mean the relation between the input and output parameters can be developed by using these various types of parameters. So first one is the Z parameters, we can also call as the impedance parameters, okay, and are also we can also call as a open circuit parameters. And Y parameters, we can also call the Y parameters as a admittance parameters, okay, and are also we can call it as a short circuit parameters. And that particular model is called as a Y or the Y model or the admittance model. And similarly, even coming to the Z parameters, I mean Z model or the impedance model. Then the another kind of parameters are the ABCD parameters, or in other words, we can also call it as a the transmission model or the transmission parameters. Then finally, the fourth one is the hybrid parameters, or we can also simply call it as a H parameters. So Z parameters, Y parameters, ABCD parameters, H parameters are impedance parameters, admittance parameters, transmission parameters, and hybrid parameters. Okay. So one by one we will discuss how we can use the Z parameters to develop the relation between the input voltage and the parameters between the input and output. Okay. So as we know, these Z parameters is also known as the impedance parameters, because as we know, Z we usually call it as a impedance. So which means here the Z parameters are used to analyzing the two-port network. Okay. So especially in the Z parameters, we represent the functions. Okay. That is the voltages, especially the V1, V2. So in terms of the current, okay. So the V1 is the function of the current I1 and I2, and the V2 is the function of the current again I1 and I2. So here V1, V2 are the functions of the currents I1 and I2. Then here, then if you write the relation between these two, the relation between the V1 and V2 are, the V in terms of the in terms of the functions of I1 and I2. So here these are the equations, which is V1 is equal to Z11 into I1 plus Z12 into I2, and V22 is equal to Z21 into I1 plus Z22 into I2. So here, then if you write this one into the matrix form, so here V1 and V2, this is a single column matrix, and here this is the Z11 and Z12, Z21, Z22, this is a 2 by 2 matrix, and I1 and I2, okay, so and equal to again Z into I1 and I2, right? So here, which means here the single column matrix V1 and V2 is also called as a voltage matrix. Okay, so this is this matrix is also called as a voltage matrix, and this is the impedance matrix. We usually call it as a impedance matrix because this matrix consisting of all the impedance elements. And this is the, let us consider this is the current matrix. We usually call it as a current matrix. So now we should know what is, how to find this Z11, Z12, Z21 and Z22, right? So here we need to consider some considerations to find each parameter, okay, each impedance parameter, okay. So which is Z11, Z21 and Z21 and Z22. So Z11, okay. So what is this Z11 represents actually? Okay. So here Z11 is equal to V1 by I1. So V1 by I1, which are the V1 and I1, both are the input side parameters for this particular two-port network, right? So which means this is input. Okay, so input, and V by I is we usually know that is a impedance. So this is input impedance. Then when you will get the input impedance, because as I told you, these are also called as a open circuit parameters. Okay, so when you are finding some parameters which are related to the input side, then the output side must be open, and if you are going to find the output side parameters, then the input side must be open. So that's why here I2 is equal to 0. So I2 is equal to 0 is nothing but we are keeping the output terminals are open. We are keeping the output terminals are open. So which means if you want to find Z11, then you should make it I2 is equal to 0, or you should make the output terminals or the port 2 terminals should be open circuit. Then only we can find here the Z11, which is input impedance, which is equal to V1 by I1, right? Then next Z12, okay. So here Z12, here it is actually the reverse transfer impedance by keeping input is open, okay. So which means here now the reverse transfer impedance, because V1 by I2, so here V1 is input parameters and I2 is the output parameters. So in this case we should keep I1 is equal to 0, so which means the input side is the open circuit, so that you can find the reverse transfer impedance, which is Z12 by keeping the input port terminals are open, which means the port 1 terminals are open. Next one is the Z22. So here Z22 is the output impedance keeping the input open, okay, the output impedance keeping the input open. So here Z22 is equal to V2 by I2, okay. So because here Z22 V2 and I2, when it is, then I1 is equal to 0. So which means by making I1 as an open circuit, we are finding the two parameters. One is Z12 and Z22, right? And similarly here, Z21 is the forward transfer impedance by keeping the output open, okay, which is V2 by I1. So as you can see here, I mean, how we can find Z11, Z12, Z22, Z21. So anyway, these all are the impedance parameters. So impedance is nothing but that is V by I. Okay. So, but here we don't know for Z11 which, we should know, okay, for Z11 which is the input impedance, okay. So what is V1 that we have to take and I1 what that we have to take, which means whether the input voltage or the input current or input output voltage or the output current. Okay. So here, as you can see here, 1 represents the input, the port 1 and the 2 represents the output parameters, right? So port 1, port 2. So Z11 means here the both voltage and because Z is equal to V by I and 1, so which means here V1 by I1. So here the two are, 1 and 1 are representing the input side parameter. So that's why V1 and I1. Okay. So anyway, if you are going to find V1 and I1, then I2 must be 0. Then Z12. Okay. Z12 here, V1 by I2, right? So V1 by I2. Anyway, here again we cannot make I2 as equal to 0 because here V1 by I2, if you make I2 as 0, then this Z12 will become infinite value. So that's why here instead of making I2 as 0, then we should make I1 as a 0, because in all the cases, as you can see, either I1 is equal to 0 or I2 is equal to 0, because these parameters are also called as a open circuit parameters, which means if you are finding the parameters, you should make it open circuit, either input side parameters or either input terminal or the output terminal. Okay. So of course we can't both, we can't make it open circuit for both the terminals. Okay. At each time you should consider one is the open circuit parameter. One is the open circuit. Okay. So that's why here in case of Z12, of course here the numerator is V and the denominator is I. So here the first letter is representing the numerator and the second letter is representing the denominator. So numerator is V, so which means 1 means input side parameter. So V1. Then here 2 is representing the output side port. So here I2. Okay. So that's why we cannot make I2 is equal to 0. So that's why here I1 is equal to 0. Then similarly Z22. So here for Z22, of course again V by I. Okay. V by I. Right here Z22, so which means V2 and I2. Again here I2 is there, so that's why we should make I1 as again 0. So which means here the port 1 or the input terminal should be open circuit. Next Z21. So again here V by I. So here Z21 means here V2 by I1. So here I1 is there already, so that's why we can't make I1 is equal to 0. So which means here we should make I2 is equal to 0. So it is very easy to remember, okay, to find Z11, Z12, Z22 and Z21, right? So again, you know already Z11 because both are referred to the input side parameters. So that's why here it is input impedance. And here the Z12 here it is reverse transfer impedance, okay, and Z22 is the output impedance and Z21 is the forward transfer impedance. So this is about the Z parameters. So Z parameters are also called as a impedance parameters and also called as a open circuit parameters. So why we are calling the Z parameters as a open circuit parameters? Why? Because here the output, when you are finding the parameters, okay, so one of the terminal of the two-port network should be open circuit. So that's why here these parameters are also called as a open circuit parameters, right? So which means why we are using the Z11, Z12, Z22, Z21, because we are developing a relation between the various parameters present in the two-port network. Then coming to the Y parameters. So here these Y parameters are also called as a admittance parameters. Okay, in other words, these Y parameters are also called as a short circuit parameters. Why? Because before in the Z parameters, okay, so to find the Z parameters, okay, we have considered one of the ports should be open circuit. So similarly here we will consider one of the ports should be the short circuit. So by making the short circuit, we usually find the parameters, okay, which are the Y parameters, right? Then yeah, here the Z parameters are the voltages are the functions of the currents, but here it is exactly reverse. The currents are the functions of the voltages, right? So which means I1 is the function of V1 and V2 and I2 is also a function of V1 and V2, which means here I1 value in terms of V1 and V2 and I2 value also in terms of V1 and V2. So now let us write the Z parameters, Y parameters equation. So which means here I1 is equal to Y11 V1 plus Y12 V2. Similarly, here I2 is equal to Y21 V1 plus Y22 V2, right? Then now we are converting these equations, or we are representing these equations into the matrix form. So here the matrix form, here the first column matrix is having only the currents, which is I1 and I2, and the equal to, and here the second matrix is the 2 by 2 matrix, which are having the all the the Y parameters, are the admittance parameters, which are Y11, Y12, Y21 and Y22, and again then the voltages are V1 and V2, or in simply we can represent, because here this matrix is the admittance matrix, so we can replace this matrix as a simply 1, right? So that's why here again, here also this one is the current matrix, the column matrix. This is the current matrix, or single column current matrix, and this is the admittance matrix, and this is the voltage matrix again, right? So simply this total represent, I mean matrix represent as a Y. So here Y is a 2 by 2 matrix, so which is Y11, Y12, Y21 and Y22. So similar way, like we have discussed in the Z parameter, so here also we need to find Y11, Y12 and Y21 and Y22, right? So here then first, if you want to find Y11, so just the opposite way, that the Z11. So here before it was Z11 is equal to, it was V1 by I1. So now here it is I1 by V1, right? So I1 by V1, and when here, because as I told you, these parameters are also called as a short circuit parameter. So that's why here Y11, so which means here the 1 and 1, okay, both are representing to the port 1, which are input side. So which means here output should be make it short circuit. So when output is short circuit, anyway the voltage across the two terminals will become 0. So which means what is the output voltage? Here it is V2. So that's why here V2 is equal to 0. Okay, so this is the input admittance keeping output short circuit, because before here output open circuit, and here output short circuit. So that's why these are the short circuit parameters, and previously the Z parameters are the open circuit parameters. Then here again Y12. So here Y12 is again here also reverse transfer admittance, okay, by keeping the input is short circuited, because here the same way here Y12, so 1 is representing the port 1 and 2 is representing the port 2. So which means here the 1 representing, we should consider the parameter input side, and 2 is nothing but the parameter refer to the output side. So anyway we know that Y is equal to I by V. So V12, so which means here I1 by V2. So anyway here we cannot make it V2 as is equal to 0, because if you make it V2 is equal to 0 like in the previous case, then here the Y12 will become infinite. So that's why here then what we should make it to 0, then V1 is equal to 0. So which means here the input side is, we are getting short circuited. Then Y22. So here Y22 is the output admittance keeping the input short circuited. Okay, so output admittance keeping the input short circuited, because here Y22 again here you can make it I by V is the admittance. So 2, so which means I2 and V2. Okay, so already V2 is there, then we should make it V1 is equal to 0. Then this is the output admittance by keeping the input short circuited, right? Then next case is Y21. So here Y21 is the forward transfer admittance by keeping the output short circuited. So why output short circuited? Anyway here Y21, okay, because again I by V. So here Y21 means here 2 is representing to the numerator. So this is I2 and this is V1. So again V1 is there. So that's why we should make V2 is equal to 0, which means the output is the short circuit. So this is the way to find the admittance parameters. So here these admittance parameters also, just we are analyzing the circuit by using this two-port network, and how we are analyzing this two-port network circuit by using the Y parameters, which are the admittance parameters, which are also called as a short circuit parameters. Then now we are moving to the another parameters, which are ABCD parameters, right? So these ABCD parameters are also called as a transmission parameters, because these kind of two-port network and these kind of parameters we usually use in the transmission line. So that's why here these ABCD parameters are called as a transmission line parameters. Okay, so but here as you can see, only the input side parameters, that is V1 and I1. Okay, because just try to compare with these three, because in case of impedance parameters, okay, there the voltages are the functions of the current. So which means V1 is the function of what is that I1 and I2, and V2 is also function of the I1 and I2. But when coming to the admittance parameters, which are the Y parameters, there the currents are the functions of the voltage. So which means the I1 is the function of voltage V1, V2, and the I2 is the function of the voltage V1, V2. But here, if you see ABCD parameters, only the input parameters, okay, which means V1 and I1, okay. So the input parameters are the functions of the output parameters, which are V2 and I2. So that's why here, as you can see, V1 is equal to F1 into, the function of V2 and I2. And similarly, I1 is also the function of V2 and I2. So now let us write the equations for these ABCD parameters. So here V1 is equal to A into V2 minus B into I2, and I1 is equal to C into V2 minus D into I2. Then again we are writing these equations representing these equations into the matrix form. So here V1, V2 is equal to ABCD, okay, into ABCD into V1 minus I2, right? So here y minus that we will see, okay, later, because before it was V1 is equal to AV2 plus BI2 and something like that it was there, but here it is having the minus sign, that I will explain why here it is the minus sign. Then of course here also similar way, this is of course we cannot say this is voltage matrix or the current matrix, because as you can see these matrix having both voltage and current, okay. So that's why we can call it as input matrix, and this is the ABCD parameter, which means transmitter parameter matrix, okay, and this is V2 minus I2. Then here A, what is mean by A? So here A is equal to V1 by V2. A is equal to V1 by V2. So V1 by V2, reverse voltage gain. Actually the voltage gain usually V2 by V1, okay, output voltage by input voltage, but here it is input voltage by output voltage. So that's what here it is the reverse voltage gain by keeping the output is the open circuit. So by keeping the output is the open circuit, because here both V1 and V2 that we have considered, so that's why here I2 must be make it to 0. So then only you can find the parameter in the A parameter in the ABCD parameters. Then when coming to the B, so here B is equal to reverse transfer impedance keeping the output short circuited. Okay, so which means as you can see here we are making both conditions here. Okay, short circuit and open circuit. But before in Z parameters and Y parameters, in Z parameters we have considered only the open circuit, and in the Y parameters we have considered only the short circuit. But here in the ABCD parameters, okay, so some cases we are considering, we are making one port or one terminal, one port is a open circuit, and another port, another case the another port is a short circuit. So that's why here just observe here. So B is the reverse transfer impedance, okay, reverse transfer impedance by keeping the output is the short circuited. So which means here the V2 is equal to 0. Then here C is equal to again the reverse transfer admittance, okay, keeping the output open circuited. So I2 is equal to 0. Then similarly here D is the reverse current gain by keeping the output is the short circuited. Okay, so which means here in the two cases we are making it output as a open circuit, and in another two cases here we are making the output as a short circuit, because in all the cases we are considering only the output what is that, are also these ABCD parameters are also called as the input parameters, okay, because V1 and I1. So why? Because here we are in every case we are making either open circuit or short circuit of the output terminals only. So we are not disturbing the input terminal. So that's why, and also here what we are, the equations also representing V1 and I1. So that's why these are also called as a the input parameters, okay. So that's why here in case to find A, B, C, D, okay. So especially the parameter A and C we are making the output as a open circuit, and when we are finding especially in the B and D parameters, so we are making the the output as a again the short circuit. Then coming to the hybrid parameters, okay. So here these are the hybrid parameters means one input voltage and one output current that we usually consider here. So that's why these are called as a hybrid parameters. Okay. So which means then as you can see here, yeah. See, from the input side we are considered one voltage and output side we are considering one current. Okay. Because this is again the fourth combination that you can see here. Okay. Because in the first combination all are the voltages. Okay. Second combination and the currents, and third combination only input, and the fourth combination one voltage and one current, and that one voltage is from the input side, another current is from the output side. So which means here the voltage V1 is the functions of the input current and output voltage, and similarly the output current I2 is also a function of the input current and the output voltage. Then similar way here also we will write the equation, okay, that V1 and I2. So here V1 is equal to H11 I1 plus H12 V2, and I2 is equal to H21 I1 plus H22 V2. So that's why here these parameters are also called as a H parameters, hybrid parameters. So now we are representing this into a matrix form. So that is V1 I2 which is equal to H11 H12 H21 H22 into I1 and I2. And similar way, like in the Z parameters and Y parameters and ABCD parameters. So here also we need to find H11, H12, H21 and H22. So here H12 is the input impedance, okay, by keeping the output short circuited. So V1 by I1, which is then V2 is equal to at V2 is equal to 0. Then similarly here H12 is the reverse voltage gain keeping the input open circuit. Okay, so which means here the reverse voltage gain here it is again the same way like in the previous case. Okay, so V1 by I2, okay, when I1 is equal to 0, which means when the input as a open circuit. Then similarly here H22 is the output admittance by keeping the input open circuit. So which means by keeping the input open circuit. So again here I2 by V2. Then finally here H21 is the forward current gain keeping the output short circuited, which is I2 by I1. So output is short circuit is nothing but V2 is equal to 0, because here we cannot make the open circuit, okay, because here I2 I1 both are there. So if you make input open circuit, then I1 becomes 0 and output open circuit I2 becomes 0. So that's why instead of that we are making the output as a short circuit. So this is the way to find the various parameters. And in the next class we will discuss what is the interrelation between these two parameters, which means how the Z parameters can be converted into Y parameters, and how Y parameters are converted into Z parameters. So and again how the Z parameters are converted into ABC and vice versa. Something like that here. We will discuss the interrelation between the various two-port networks in the next class. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.